for recording. Okay, so that should be, yeah, that should be recording. Right, so we'll go over the questions from the mastery tests, and then maybe if there's something specific that you want for us to talk about, then you can go over that as well. So I've printed off the questions from the mastery test, but the numbers might be different from what you've got because the numbers have been randomized during the test. So these are the numbers that I've got. We'll just go through the solution, and then you just, if you want to go over your work, just put in the numbers that you've got in your question. So here, it's a conversion question. So there's a severe sunburn, and the area of the sunburn is given in centimeters squared. So the sunburnt area is given in centimeters squared, and you want to convert that to meters squared. Okay. So whenever you're doing conversion, you need a conversion factor. It's what relates the two units that you want to convert from and to. So here you need to have a conversion factor. You can refer to the slides on prefixes where centi, this is the prefix centi. Centi means times 10 to the minus 2, or you can also use your prior knowledge. If you know that 100 centimeters equals 1 meter, you can also do that. So you know that 1 centimeter is equal to 1 times 10 to the minus 2 of the meter, because the prefix centi is 10 to the minus 2. Or you can expand that even. 1 centimeter is equal to. So the scientific notation, if it's a negative exponent, okay, the decimal place is sort of assumed to be at the end of the number. And if the exponent is negative, you move the decimal place to the left. So 1, 2, the new position for the decimal place is there. So 1 centimeter is also equal to 0.01 meter. Yeah. Okay. So Ruth, if you have any question at all, just pop it in the chat box, or you can just unmute yourself and join in and ask your questions, whichever way you prefer. So once you have your conversion factor, that's the most important thing. Then you have what you want to convert is 41 centimeters squared. You can write that as 41 times 1 centimeter times 1 centimeter. Centimeter squared means that there are 2 units of centimeter there. But, yeah. And so when you do the conversion, you have to do the conversion twice. Centimeter squared also means centimeters times centimeters. Okay? So you can write down centimeter squared as like this, 1 centimeter times 1 centimeter. Okay? Then you use your conversion factor and replace whatever unit you don't want. So you don't want the centimeter unit. Use your conversion factor. 1 centimeter equals 0.01 meters, which means you can replace 1 centimeter with 0. I can stop working. 0. I'll have this problem sometimes with this pen deciding to act up. 0.01 meter times 0.01 meter. You can see there we did the conversion of centimeters to meters twice because it's a centimeter squared. Okay? And then get your calculator and do the multiplication. 41 times 0.01 times 0.01 should give you 0.0041 meters times meters, that's equivalent to saying meters squared. So that should be choice A. Okay, does that make sense? Yeah. Are you okay with that, Ruth, or do you have any question? Okay, cool. All right, the next question is a graph, about the graph, interpreting this graph. It shows the velocity, so y-axis is velocity and x-axis is time. Shows the velocity against time for a ball that's moving under free fall, under gravity. So it was thrown upwards initially, and this is how the velocity changes. So we know, yeah, if you have a ball or an object, let's see what's going on with this one. An object, you give it an initial velocity upwards, no, it will travel up and then eventually it will reach its peak. At that point, it will momentarily stop before it will start going down again. So going up, the ball will lose speed, and then going down, it will gain speed. So sort of if you look at this graph here, from 0 to 2 seconds, this is the first part of the graph. You have the speed is decreasing. It's going from 20 meters per second squared, and it's decreasing until it reaches 0 meters per second squared. At this point, the ball is at the top of its motion. Right? And then the ball starts to go down. As it goes down, it picks up speed. So this part here is going down. So notice how, yeah, the numbers here are becoming bigger. Although they're negative, it means that the object is going down, downward direction. And this part here is going up. Yeah. So in which direction is the ball moving at 1.5 seconds? It's at this time. So that means the ball is at that point. It has positive velocity, but decreasing velocity. So that means it's going upwards. Right? Okay, that makes sense. All good, Ruth? Yeah. Okay, let's go to the next question. A car is moving at 4.7 meters per second. The car changes speed so that it covers twice as much distance, but in half the time. Right? What is the new speed of the car? So we know speed is equal to distance over time. Distance covered divided by the time it takes. So you're covering twice the distance in half the time. Okay. Right, so twice the distance, but you're just spending half the time. So that means you should be moving faster, right? Because you're moving faster because you're going farther, but with less time. And twice as fast, twice as much, but half the time, that means your speed is 4 times. Okay. That means new speed should be 4 times the original speed, which is given. 4.7 is the original speed. So multiply that with 4, 18.8 would be the new speed. Is that okay? Yeah. Are you okay with that, Ruth? It's actually just Ruth and Lisa. So yeah, we can talk about anything that you want. Yeah. Is that okay, Ruth? All good. Cool. Thanks for that. The next question here shows us the speed of the ball that's rolling down a hill. And it wants us to find how far the ball travels between 3 seconds and 8 seconds. Okay. So if you look at the y-axis, that is speed, and the x-axis is time, right? And we want to find the distance. Do you think we should find the slope or the area? If it's speed. So if the graph is speed versus time, do you think we should get the slope of the line or the area between the graph and the horizontal axis? Yeah, we want the distance. We're given the speed. Yes. Yeah. So if first thing to check what's given in the y-axis. If you're given the speed and you want the distance, you get the area. If you want the acceleration, get the slope. Yeah. So that means get the area between the graph and the horizontal axis. And that's between 3 and 8 seconds. So that's 3 and 8 seconds. So you want this area here. You want to solve that area there. If you look at the shape, yeah, you're sort of the graph together with the boundaries of, of where you want to find, of the time where you want to find the distance, you will see that the shape traces out a trapezoid. Yeah, a trapezoid is a shape where you have two parallel sides. So the side on the left and the side on the right, they're parallel, and two sides that are not parallel. So the one below is not parallel to the side above. So it traces out a trapezoid, and we have the area of a trapezoid. The area of a trapezoid is 1/2 times the height of the trapezoid. I should write that in a more space. So the area of a trapezoid is equal to 1/2 times the height of the trapezoid times the sum of the bases, base 1 plus base 2. So the base, those are the sides that are parallel. So that's base 1 and this is base 2. The sides that are parallel, we call those bases. And the height is the distance between the bases. So this is the height. That's the height of the trapezoid. All right. Yeah. Okay, so let's read off the numbers from the graph. So the height goes from 3 to 8 seconds. So that will be 5 for the height times base 1. You sort of have to read what's the length of this. So it goes, so this is 5. So half of that will be 4.5 and half of that will be around 4.25. So this point here is about 4.25 for the length of base 1. Yeah. Plus the length of base 2, it's this length here on the right. So it goes from 0 to this point, and that point is 12 meters per second squared. So that's the length of base 2 is 12. Yeah. we do the calculation. So when you enter this in the calculator, make sure to include the brackets. Otherwise, some calculators will just multiply 5 with the first number. But we want to add these two first before multiplying, and you should get 41.25 for the answer. And that will be meters because it's distance. Is that all good? Yep. Are you okay, Ruth? Are you still okay? Yeah, cool. Next question. An airplane is flying with this initial speed, 1,000 kilometers per hour. And then it changes speed to 1,010 kilometers per hour in 10 seconds. Okay. Right. And then below, there's a cyclist who is initially moving at 3 kilometers per hour. And then he or she also changed speed, going to 8 kilometers per hour in 5 seconds. And based on that scenario, there are questions here, and you're asked to select which one is correct. Maybe I'll make that a bit bigger. Yeah, does the cyclist have a larger acceleration because they're moving slower, or will they have a larger acceleration because they changed the velocity in the shorter time, or do they have the same acceleration, or did the airplane have a larger acceleration? So if you look at the choices, yeah, because the tests will also be multiple choice, similar format as the mastery tests. So sometimes it's also a skill trying to eliminate, what's not possible in the choices. So if you look at the choices here, it's all talking about the acceleration, right? So that means you have to figure out the acceleration of the airplane because it changed speed. So it would have acceleration, and compare that to the acceleration of the cyclist when the cyclist changed speed, right? We know acceleration is change in velocity over change in time. And we're given the final and initial speeds. Kilometers per hour, that's a unit of speed. So this one is speed, or VI, that's VI. And this one will be VF, right? So here also VI, VF, and we're given the time. That's time. Yeah, so the shortest way to do this is compare what's the change in speed of the airplane and the change in speed of the cyclist. So the airplane, for the airplane, it went from 1,000 kilometers per hour to 1,010 kilometers per hour. So that's a difference of 10, right? So that's kilometers per hour minus, so that's a difference of 10 kilometers per hour in 10 seconds. Yeah. And for the cyclist, final minus initial speed, it went from 8 kilometers per hour. Oh no, it went from 5 kilometers per hour to 8 kilometers per hour. So your final speed is 8 and your initial speed is 5. So that is 3 from 8 to 3. Yeah, I sort of, my brain said the answer instead of the, so that will be a change in speed of 5 kilometers per hour for the cyclist. This pen just keeps. Doesn't want to write somewhere here. What's going on? Five. Apologies, I'm using my finger. This is what works. So that's a change of 5 kilometers per hour in 5 seconds. 5 seconds. But if you compare the change in speed for the airplane, it's 10 kilometers per hour in 10 seconds. For the cyclist, it's 5 kilometers per hour in 5 seconds. So half the change in half the time will give you the same acceleration, right? It's still an acceleration of 1. Yeah, a change, yeah. Change in speed of 10 over 10 seconds is the same as change in speed of 5 in 5 seconds, right? So that means they should have the same acceleration. Does that make sense? Yeah. Does that make sense, Ruth? Yeah, good. If we were to find the actual acceleration, make sure you convert kilometers per hour to meters per second, because your time is in seconds. But in this case, we just wanted a relative comparison between the change in speed between the two. And so I didn't convert kilometers per hour to meters per second. Yeah, but if we wanted to find the actual value of the acceleration, we have to convert kilometers per hour to seconds. And there's a shortcut for that. I'll give you the shortcut for converting kilometers per hour to meters per second. Just divide by 3.6. So kilometers. Oh, I want to write maybe here. Anyway, kilometers per hour. If you say we want to 1,000 kilometers per hour, convert that to meters per second, you just go 1,000 kilometers per hour divided by 3.6 seconds. I don't know if Ruth can see the board like that. So 1,000 kilometers per hour. If you divide that by 3.6, you'll have whatever value meters per second. So that's the shortcut between conversion. Because you'll be doing a lot. I think even in the test, sometimes we'll give you kilometers per hour, and you have to convert that to meters per second. So you can go through the long route of converting kilometers to meters using the conversion factor. 1,000 meters equals 1 kilometer, and also 3,600 seconds is equal to 1 hour. So these are the conversion factors you'll need to convert kilometers to meters and hours to seconds. But yeah, you can just use the shortcut of dividing kilometers per hour, divide that by 3.6, you will get the meters per second conversion. So that can be useful, especially in the time constrained tests. All right. Are you okay, Ruth? Do you have any question, or we can move to the next one? Okay, good. So question 7, there's a mantis shrimp propels its claws forward from rest. So let's pick out information as we encounter them in the problem. So it goes from rest. That means the initial, I don't know why this pen. So from rest, that means the initial velocity is 0. And my pen just stopped working altogether. Let me just reset this. It means initial velocity is equal to 0. And with an acceleration of 10,000 times the gravitational acceleration. So you're given the acceleration, this is acceleration. I don't know why it wants to write in some parts and it's not writing in other sections of the document. So you're given the acceleration, we're given the initial velocity, VI, and then it says it delivers a knockout stun and captures its prey. It's able to achieve such a large acceleration because the energy stored is released over a very short time scale. So we're given the time. Time is also given. Right? If you were to determine how far, so how far that is x, what's going on with this? It's not writing in some sections. How far? That means we want to find x. Which equation, which of the kinematic equations should we use in order to calculate for x? Okay. So yeah, that's why I tried to pick out which information is given in the problem, because we know when we use kinematic equations, it's just figuring out what we know and which equation to use. So we're given VI. VI is given. Yeah, it's from rest. And we know time, we know acceleration. What's not given is VF. Right? We're not given the final velocity. So any equation here that contains the final velocity cannot be used, right? Because we don't know anything about the final velocity. The problem doesn't say that. So which equation can we use to find x? Is it A, B, C, D, E, or F? Yeah, so D is the only one that doesn't have VF. Do you agree, Ruth? Do you agree that we should use equation D in this case to find x, the distance? You're still confused why? Okay, so in the kinematic equations, notice how it contains 4 variables. So let's look at this. The first equation, it contains VF, that's the final velocity. It contains VI, the initial velocity. It contains A, acceleration, and it contains delta X, the distance. Okay, so so you can use equation A to solve VF if you know VI, A, and delta X. Right, so that's the way to use the kinematic equations, is figure out what you know. And then based on what you know, you can choose which equation you can use that contains the information that you know. So if we go back to the problem, it says the mantis shrimp propels its claws forward from rest. So from rest means VI is given. It means VI is equal to 0. Okay, if my pen, I don't know what's going on with my pen. Hopefully you can see the board. Are you able to see the board from the video camera? Okay, so we're given VI that's equal to 0 because it started from rest. Yeah. Okay, and then it also says there it has an acceleration of 10,600 g. So your acceleration is 10,600 times 9.8. G is the 9.8 meters per second squared, the acceleration that you encountered in free fall. Yeah, so you know A. A is given in the problem, acceleration. And then the problem says blah, 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 bunch of words. And then the last sentence says the energy is released over a very short time scale. And it gives you some time there. So that means the problem gives you some information about the time, 0.003 seconds. Yeah. And then if you read on, there's nothing else. So next one is now the question. If you were wanting to determine how far, so how far is X distance, delta X. Delta X is how far, that's what's being asked. You're being asked to find delta X. Okay, which equation should you use to do this? There's nothing mentioned about final velocity. So VF, you don't know. You don't know any information about VF. Okay, right? So that means when you go to your equations and pick out which equation you should use, because you don't know VF, you don't know the final velocity, then you cannot use any equation that has VF in it. Yeah. Does that make sense? Right. So the first equation, yeah. Okay, good, good. Right. First equation has VF, so does equation B. Equation C also has VF. So only equation D doesn't have VF. So that's the only equation you can use to find delta X. Yeah, good. Right. In the end, it makes sense. So that's the important bit. Right. Cool. Yeah. And the last question, yeah, here. There's a cat that's chasing a mouse, and the cat is running 5.9 meters per second to the right. And during the chase, the cat notices a dog which starts chasing the cat. The cat slows down and stops, and then starts running to the left. And after 1.5 seconds from the beginning of the chase, the cat is moving at 8.7 meters to the left. And what's the average horizontal acceleration of the cat during the 1.5 second interval? So note here, the 1.5 seconds includes the time when the cat was chasing the mouse. So initially, the cat was, yeah, my pen stopped working together now. So, yeah. Try this one last time and see. No. No, it doesn't want to. So you have, yeah, you can see the board all right, yeah? So your initial velocity, the cat is going to the right. Okay, that is positive 5.9 meters per second. We go to the right is positive. And then it stops and then goes back. And after 1.5 seconds, it's now moving at 8.7 meters per second, but it's to the left. So you have this negative sign. So the negative sign means the cat is moving to the left. And the time interval between the two is 1.5 seconds. Okay. So from the time the cat was chasing the mouse to the final time when they gave you 8.7 meters per second, the time interval is 1.5 seconds. All right. Just checking if she can see the board. And they want you to find the acceleration. So from definition, acceleration is the change in velocity over the time interval. Whenever we say change, that's final minus initial. So final velocity minus initial velocity divided by the time interval. Okay, and we know all the information. Just make sure to include the negative sign in your VF. That's negative 8.7 minus your initial initial velocity is positive 5.9 because the cat is moving to the right. And divide that by the time interval 1.5. 1.5 seconds. Yeah. Does that make sense, Ruth? Are we okay with setting up that equation? Yeah. Okay, so when you put that in your calculator, you should get negative 9.7 meters per second squared. Meters per second is same as meters per second squared. All right. Okay, and I think that's the last question. Yeah, that's the last question in the workshop. So I don't know. I think we're okay with the workshops, unless you have anything else you want to talk about the workshops. Yeah, right. I think it's okay, and you're okay. So, right. So, is there anything else you want us to talk about? Oh yeah. Oh yeah, yeah. Right. So the mnemonic we're using for that is Sokatoa. Or maybe I can do that here so Ruth can see it. Yeah, so Ruth, the question was, is there like a cheat way of knowing the trigonometric equations? The mnemonic we use is Sokatoa. It's called, hopefully it will work here. Sokatoa. The S in so stands for sine. So the sine theta is when you have opposite side divided by the hypotenuse. Ka, C means cosine theta. That's opposite divided by hypotenuse. Cosine theta is equal to, means adjacent divided by hypotenuse. And TOA, T stands for tangent theta, is equal to opposite side divided by the adjacent side. So that's the mnemonic we're using to remember the basic trigonometric equation. Sine theta is equal to opposite side over hypotenuse. Now, to remember whether it's a sine or a cosine to find the x component, I think we don't have a mnemonic for that, but as long as the angle is measured relative to the horizontal, it will always be a cosine, cosine theta for x component. Yeah. I don't have a mnemonic for cosine is x component because I think of it as a Sokatoa. Yeah. So if you remember ka is cosine equals adjacent over hypotenuse, and you imagine the triangle and the adjacent, yeah, if you imagine the triangle, and the theta is always that angle measured with the horizontal. And you remember ka, and you say, oh, adjacent is this x component. So that means it has to be a cosine. So it's the adjacent of the hypotenuse. Yeah, and this or this one,
No, the car.
the car. Yeah.
So is the equation to find the angle or is it to find the other side?
To find the other side. It's to find the adjacent, side. And then for the saw is to find the opposite side. And then for the angle is this TOA. The assumption is that for you to find the angle, you should know the two sides. And that's why that's the TOA is when you need the two sides, the opposite and adjacent sides. Yeah. So yeah, I guess that's the mnemonic. SOHCAHTOA is yeah. I think it was in my slides, but I didn't emphasize it because I know it is a lot of information all at once. Yeah, but that was the SOHCAHTOA that was in the slides. Yeah, you are, however, free to refer to the notes. Everything's open book, even for the test and exam. Yeah, but I know it takes time to go over the notes. So my suggestion is, while as we're going along, try to have a formula sheet where you're also writing down equations as you encounter them. So when it's time for the test or exam, you already have like a single formula sheet. Yeah. Yeah, it's the same trick you can do. Yeah, all right. Yes. Yeah. Right. Anything else? Ruth, do you have something you want to ask? You're good. You're good. Yeah, maybe if you like, we can talk a little bit about the second lab, because that's up on stream and that's due next week, I think. So if you want, we can talk a little bit about the second lab. Is that something you'd be interested in, Ruth? That's the lab. Oh, I probably. Yeah, for the second lab, it's okay, a little bit about the first lab first. So in the first lab, we asked you to walk and you measured your distance and how fast you walked. And from there, you calculated your speeds. And we asked you to repeat that at least 5 times. So you had a range of, hopefully you got a range of speeds, because it's not probably your measure. Maybe at one point you were walking faster than the other time. So you should have a range of speeds there. And that's where we ask you to estimate the uncertainties when you had to get the average and figure out what's the range of values relative to your average. So say your average speed was 2 meters per second, and then your fastest speed was 2.1 meters per second. So that's a difference of about 0.1 meters per second that you can say my range of values is within that point. For the second lab, it's still the same thing, except that we ask you to make a graph of your speeds and of the speed and the frequency for which you have a particular speed. So you can go over the task, and the video on stream is really very good. It guides you through the task. But what you'll need for your homework is to again walk, get the distance and your time to calculate your speed, but this time using a different terrain from experiment 1, from the first lab homework. So it could be uphill or downhill or up the stairs. So if you're just confined in your house, you can go up the bed, down the bed, like a different terrain. Repeat that again 5 times. So you will again have a range of values there. And then you will be asked to plot, to make a graph of your values. A graph called histogram. So this is how a histogram looks like. This is an example of a histogram here that plots the frequency, maybe frequency is not so intuitive, so let's do an easier example in the beginning here. Yeah, this is graphing the speed of Anne, how fast she walked for how many trials? Yeah, for eight trials of walking. So at some point, at some time, it took Anne about 17. The formatting of this is so that's 17 to 20. It's not 17 plus 20. So they divided, like, okay, the time is from 9 to 12 minutes, from 13 to 16 minutes, from 17 to 20 minutes, 21 to 24 minutes, and so on. So they divided the total time using intervals, and then you sort of plot how many times did Anne walk for 13 to 16 minutes. For example, this first part here, there's only one measurement that's between 13 and 16 minutes. You look at the data here, there's only one time when she walked from 13 to 16 minutes. It's this data point here, 16. And then between 17 to 20 minutes, there are 3 data points where she walked for 17 to 20 minutes. So you have the 17, 18, and 20. Okay, that's what's plotted as frequency. It's how often she walked over the time interval. Okay. So you'll do the same thing with your homework. You'll walk a certain distance, time that, and then calculate your speed, and then make a graph of how many times you were walking 5 meters per second, how many times you were walking 5.2 meters per second, for example. Okay. So that's the histogram that you have to draw, but you have to draw 2 histograms. One is when you have the new terrain, and then another one was your data from last time. Okay. If your speeds from last time were all the same, such that there was no spread, then you have to repeat your measurement. So it's sort of suspicious to have the same speed all the time. Right? It might be okay to have the distance the same all the time, but I'm pretty sure you cannot walk the same pace all the time, right? All the 5 trials, you will have different times for walking the same speed. So those are the two histograms that I want to see. Let's go to the homework page. Okay, so the homework page asks you here, there's a graphing paper provided. This is where you will graph your speeds. So the x-axis should be speed, not time. Right. And again, a clear description of how you collected your data. Write your raw data, so write the distance that you walked and the time it took you to cover that distance. So you should have at least five trials for measuring the distance and measuring the time, so that you'll have 5 values for your speed. Okay. And then here there's a question of how your walking speed changed. And there will be a range of answers there depending on which terrain you've chosen for the second kind of terrain. And I think, yeah, that's it. So once you've given a description of how you determine your distance and time to calculate your speed, you'll get a mark for that. Quality and quantity of data, I'm looking for like at least 5 trials for the time for your speeds. Quality is looking at, something suspicious would be if you have the same speed over 5 trials, right? Which means, which could mean many things, but the likelihood of walking with the same speed over different terrains is quite unlikely. Yeah. And histograms, yeah, plotting, I would be looking at the data. That's why it's important for you to put the raw data so I can compare. If you indeed put in your graph, you said that I walk 5 meters per second. There are 2 trials where I walk 5 meters per second. I have to check that against your raw data. And then, yeah, analysis of the histograms is when you answer the question, how did your speed change in a different terrain? Yeah. All right. So I think that's the second lab. And as I said, the video on stream is really informative. It's really detailed. So go through that and then it will guide you through the tasks. That's like your practice before you do the homework. Yeah. Okay. Anything else?
Is it right to consider any like the distance being different than like the first term?
Yes. Yeah, because it will be the speed. So yeah, you're right. Because if you, for example, covered a longer distance, your time should adjust accordingly. So then your speed would also adjust. So we are plotting the speed instead of the distance, so it should be okay to have a different distance. Yeah. All right. Ruth, is there anything you want to talk about, or do you have any questions? Oh, good. Anything else? Oh, yes. Yeah, please do. I know the video says to write as a text. It's because they have 300 students down there and for them to go over and upload. But it's actually easier for you to just use this last page and write your answers there, upload a PDF. At least the graph should be in PDF. But yeah. Yeah, just upload the PDF of this 2 pages. Yeah, I guess what we're trying to avoid is students uploading 10 pages of PDF of explaining what they did when you can explain that in a few sentences.
It's just that just the Instagram that we have to do that we don't upload to this.
No. So you only just need to upload this last 2 pages that says homework. So we will not really mark the first part. It's just like practice for you to sort of understand what's going on before you do the homework. Yeah. So that's homework 2. Okay. I think next week we'll go over some practice problems for the test because your mid-semester test is coming up. The announcement hasn't gone out on stream, but it will be around April 6th, the week 6 before the mid-semester break. So I think next week in the review workshop, we'll go over revision questions for the test. Yeah.
Yeah, I mean, there are those worksheets that the extra ones that are being uploaded on the screen.
Oh yeah, that's good. Yeah, that's good because some questions there are repetitive. So it gets you used to seeing, and sometimes you see a pattern that, it's physics and math, they're just recipes sometimes, and you just have to know like the step 1, step 2, step 3, and if you do it systematically, then you can apply it to a large number of problems, the same steps. So doing the weekly worksheets where it's repeating all the time, you sort of get used to, like rearranging and converting, that sort of stuff. So how many questions in the mid-semester test? We're setting the questions at the moment, but we're aiming for 40 marks. So it doesn't necessarily mean 40 questions. Some questions could have 2 marks each, 2 marks assigned to it. So maybe it's about 30 questions, and that's a 2-hour test. Yeah, it's online. You can access it via stream, and it's open everything because it's online, and you'll do it in at home or in your own space. So yeah, there's nothing stopping us from you Googling or checking your notes. So it's open everything except, of course, asking your classmates or other people. But you can refer to the textbooks or notes.
Or specific time, so I think we want
Yeah.
a specific time, because it's also constant report, so that
Yeah.
it wasn't 24 hours.
Yeah, that's something that we are confirming because we also have a distance offering. So we're confirming that, and then after we've confirmed that, an announcement will go out on stream. But I'm aware it's a Wednesday and we have like this 9 to 11 class on Wednesday. So if it's a specific time, I would, Palmerston North also has a Wednesday morning lecture. So it will most likely be in the afternoon. It won't clash with any of the classes that we have. Yeah, so keep an eye out for the announcement. Yeah. Right. Otherwise, I know it's a shame we're all online and sometimes it's easier to explain things face to face, but I hope that the lectures and workshops are helping, um, are okay. Yeah. All right. So I guess if there's nothing else, we can wrap up this session. And then if you think of any question at all at any time, just feel free to email me or ask me in the next lesson or workshop. Yeah. All right. Okay, good. Right. Thanks for coming along and have a great weekend. You too. Yeah, thank you. I know. Like, yeah, I stopped recording.